Good morning. Welcome to the DX Radio Shop. Number one place to go to where you learn everything new and exciting. No doubt. Today we're going to talk about symbols. Different componentry level of symbols. What are they and how we should read those into a schematic. Very interesting topic, really, because a lot of guys struggle with that. And ones who get a hand license will see these symbols on your test once in a while. So it's always good to learn. And if you ever got something at home you want to try to identify as a part and repair, you'll be able to do exactly that. So just understand the trail and the path in which they go. Now, let's take a look here and see. Get this any tone out of the way. I have more any tones to do, so we have another one here on the bench getting ready to do him. So, but today we're going to start by doing a symbols. What kind of symbols are there, and how do you identify them? Well, that's what we're going to do. So, hello, Michael. Good morning. A lot of you guys already know this stuff, so it may be a boring video. I don't know. We try to make it exciting as much as possible, yet educational. So let's start with the most common. We're going to start with the transistor.
Good morning, gang. Stu is live.
Probably wondering why am I doing it twice, right? So this is your simple transistor symbol. However, why did I draw it twice? Well, here's the reason why. Because it's the way the flow of the electrons are. Okay, so these here are NPN because it's the arrow pointed away to ground, so it's your negative, positive, negative. So this would be considered N, P, N, and this one would be reverse. It's positive flow in, so this is actually a P and P. And the pinout would be emitter. This is your base, and this is your collector. Same thing over here. Emitter, base, collector. All right. So there's two basic symbols for transistors. Now they vary as to what you're looking at, whether it be a box symbol. It could be a box symbol like this, we'll say, for like a regulator. It could be, I don't know, let's go like this, right? You might see that in a print. You might see a line here, a line here, and a line here. So we'll call that a 7812 for a 12 volt regulator. It could be a 7808, 7805, whatever, right? So we're just going with a 12 volt, right? So this would be your VCC meaning, let's say you got, I don't know, 18 volts going in. This is your ground, and this would be your VCC out. Meaning, if you have 18 volts, we'll say, going in, this will supplement here to regulate down to 12 volts out. Okay, so that'd be your in, and this would be your out. So you might see a box symbol like this representing a transistor of some sort. Typically, it would be a regulator, but this would be your basic common practice here with those. Now, if you're looking for, let's move on to a different formality of things. We'll say, okay, how about maybe we can talk about like integrated circuits, right? Well, there's different ways to integrate a circuit. So we could do, we'll just do like a simple deal here. You might see like a little divot here, and you might see like a little circle on this side. That indicates pin 1. So this would be pin 1, and then we'll just make this an 8-pin chip just for reference. Okay, and that would be your IC, or integrated circuit. Okay, real basic. We'll get into also, like, say, we can do resistor. Well, let's put that down below because these are all semiconductors. We'll kind of make it like a list if we can. We'll separate. So let's go to your basic semiconductors. Let's go with a resistor. This is a fixed resistor. That is a fixed resistor. Okay. A variable resistor. Would be this. That is a variable resistor. And so there's different formalities of how they do the symbols as well. You might see a box like this. You might see something like that on a circuitry. Typically you'll see something like this, or you maybe see something like this. Okay, but these would be variable because anything that points in makes this a variation of your value. In this case would be resistance. That's a fixed resistor, variable resistor, box formation of this. Okay, now let's do a capacitor. That is a fixed capacitor. However, there's no polarity. So because of this, we do not have any direction of voltage. So therefore, this becomes a what we call a fixed ceramic capacitor. So it's a ceramic, okay, cap, and now a polarized cap would be a curve and a plus mark. That makes this I think I spelled that right. That's a electrolytic capacitor. Okay. Just think of electric, and you always know it's got to polarize. Now, you might see some of these different as to, say, now that one here with an arrow becomes variable. Yes.
I was listening to the Elster Ramshaw radio.
Yeah.
They've already got the location for the Super Bowl planned for the next 2 years or 3 years.
Where's it gonna be?
Next year is San Francisco. The year after that is Los Angeles, and the other one's somewhere in California.
Where's this one?
This one's in New Orleans.
This is Louisiana.
Yeah.
This should be decent temperature then. Should be a good game.
Apparently, they got a whole list of requirements.
Okay.
You gotta have a certain dome. You gotta fit a bunch of people in the hotel room. You gotta have at least 2 golf courses and 2 bowling alleys.
2 bowling alley? 2 what? Why? For recreational?
Apparently, that's what they do before the game.
Okay. Jeez. Alright. So a ceramic capacitor you're going to see is what we call like a pancake. All right. Electrolytic you're going to see is a what we call tubular, or what we call radial. So this will be like a. I'll put your negative polarity there. That's a electrolytic, but this is a radial. Now the axle that would be an axle type. Okay, these both here are going to be electrolytic. Just either they lay down when they're coming out the sides, or they stand up and they come out the bottom. And this is what we call the pancake. We always call these pancake caps because they're flat and orange. Well, okay, so those are your basic capacitor symbols that you will see in circuitry. And these are your resistors, and you got your semiconductors up on top. Okay, so now we've already talked about our integrated circuit, which is pretty basic. I mean, you'll see those all over the time too. So now you might see something different as far as, let's say, I don't know, an op amplifier of some sort. So you're going to see maybe like an inverted. You might see a symbol like this. Okay, that could be the same thing. It's still an IC. This would be an op amp. Now there's so many different ways we can get into with these type of components, but we're not going to discuss that. We're just showing you symbols, okay, what they are. So when you actually read a schematic, you can actually see the symbol. You say, okay, hey, I see this. The arrow's pointed away. That has to be NPN transistor. This has arrow pointed in. It has to be PNP transistor. I see, this on the print. It's got to be some kind of an op amplifier, whether it be single or dual op amplifier. I see just one squiggly line. Well, that's got to be a fixed resistor, which means current goes both ways. This here would be a variable resistance. Oh, I see just this. There's no polarity. That's got to be a ceramic capacitor then. And this one here is a plus mark, which means this is polarized electrolytic. Okay, so kind of give you an idea. If you see symbols like this, it's a variable capacitance, like a tuner, we'll say. Okay, like how you have your AM FM radio stations, right? You go to turn your stations. You're changing that with a variable tuner to tune the stations. Have a good day, buddy. Love you. See you. Now let's talk about diodes. A diode allows current one direction. That's your basic diode. Now, what if we have an LED? And people say, well, what's the difference? Well, this is a lighting emitting diode. It's still a diode, but it's a lighting emitting diode versus a diode. Okay? This is your cathode. This is your anode. Now you might see another symbol similar, but you might see this. That is a Zener diode, which is a voltage control diode. Okay? This is a switching diode typically. And your LED one would be you might see it like that. You might see a circle around it. Okay, those would be your LEDs. Everybody following right along so far? I hope so. There'll be a quiz at the end. Now, we can also see, well, let me do another one up here. I forgot actually. They just reminded me. You might see a resistor like this with an arrow through. That's also a variable. Anything that attacks the metal is going to be a variable. Okay? So now, so my daughter just came out and said, "Snow day?" No. Okay. Anyway, so that's your basic componentry, anyways, guys. So let's get into like our inductor. That's your transformer symbol. You can see the inductance with this. This is a transformer here. Okay. You can see coils such as that would be your inductor. That's pretty much really about it. Oh, you know what? You're going to see voltage somewhere too, so we got to show you voltage. So here's your ground symbol. You might see this. You may see a battery symbol such as that, or you might see series of them. Okay. Trying to think what else they've got off the top of my head here. This is pretty much give you a good random start, anyways, as to what you're looking for. So these are your basic symbols, really, for any kind of componentry inside of a schematic. So that should get you a running start. When people are looking about symbols and whatnot, I've had many people ask about symbols, so it's a great topic. And so I thought, well, we'll get the day kicked off with this. So now you see the symbols between your semiconductors, resistors, capacitors, LED diodes, transformer, inductors, battery symbols. That pretty much gives you about 99% of what you're going to be looking at on schematics. It's all in how you read them now. So outside of it, really nothing more to discuss. Just kind of give you a basic rundown as to what these are, so you know what to look for when you're actually reading schematics. So for example, let me I gotta do this today too. There we go. Come on, you. Work. Okay, so a lot of these we just discussed, right? You guys can see most of these right now on a print. These are your transistors. These are also known as regulators. With that number, I can justify as being a regulator. But these are transistor symbols. Okay. Right here, remember the little line I told you? There's a line inside the box, and it says VR1. That is a variable resistor. I forgot to put down meters. Actually, right here is a meter. A is for current. Another meter. V for voltage. Who's texting me now? Okay. So got your resistors. They're using boxes, but these are all resistors. There's another regulator, but that's a transistor symbol. Here's your capacitor. So they use this symbol here, where it's dark on one side and kind of a box on the other side. That's your polarity, which means this side here would be your plus. Okay. Remember we talked about Zener diode with that little squiggly lines? 16 volt regulated diode. That's a Zener diode here. Okay. They have an SCR, which is a different formality of a transistor. Okay. Another variable resistor here. Ceramic capacitor, just two straight lines. Here's an integrated circuit, which is known as a voltage regulator as well, with this chip and what it does. But there's your op amplifier with a series of transistors inside as well. I forgot to write down fuse. Here's your fusible link. So a couple things I forgot to do. Here's your diodes. That's part of your bridge rectifier. There's a half wave here, and you got a full wave here, and you got a bridge rectifier right there as well. You got a fusible link here. So Remember we talked about that regulator? How they got like a little box formation? Here's your ground symbol. IC3 7812. Well, that's going to be your voltage in. Probably 1820 volts coming across here. Ground out to this point. That's going to be your 12 volts. Right here's 12 volts. Because that's what this regulator is. So these are all the symbols you guys will see to identify on a schematic as to, well, what is that thing? All I know is it's some kind of a weird looking, thing. So now you know what this thing is, right? So it says 2.2, so that's the 2.2 ohm resistors across here. 470 ohm, etc. If they were anything more, it would say, like down here, 1K5. That means it's a 1.5K ohm resistor. All right. So don't be misled by what these numbers are. You have to understand them. 2.2 versus where'd you just go? Right here. So it's 1.5 or 1K5. That means 1.5K, 1,500 ohm or 1,500 ohms. Okay. So now you guys got an idea in a good educated class this morning as to what these symbols are. So when you read a schematic, you'll know exactly, okay, hey, I got something wrong with this. I don't have the voltage. What is that? Oh, that's a transistor. I remember now. It's a transistor. Okay. Now I got to find out what caused the transistor to fail. Or is something pulling that transistor down? Is it a switching transistor? Is it used as a regulator? Is it used for what purpose? So now you got to identify all of that as well, which is later down the road. But at least you can identify a symbol, so you know what you're looking for. If you're trying to find a part, you can say, okay, that's a transistor. Or I need a capacitor right here, 1,000 microfarad by 25 volt. I need a capacitor. And if I have this and it shows voltage, that tells me, uh-oh, that's a polarized cap. It's not a ceramic capacitor. I got to make sure I put the right value capacitor in circuit. Okay, so everybody understand that? Pretty cool, awesome. I'm glad y'all paid attention. So again, there's your symbols. Great topic. So thank you for the ones who emailed me. There's a couple of guys who had emailed me about this for the topics on this. They were kind of wondering, can you talk about symbols, because they're trying to learn schematics, and I think that's a wonderful thing. So keep up the good work, guys, and carry on for sure. So. Anybody got any questions? Drop them down below. Let me know what your thoughts and ideas are, and all that good stuff. So, got quite a few people in here today, no doubt. Coils and crystals. Well, these are your coils right here, your inductance. You might have different formality of coils. As far as crystals go, well, there's a couple different things you can utilize with that as well. Open up. There we go. So a crystal, I'll show you on here, we'll draw it out at the same time. A crystal is going to be right to there, which is basically just a line with a box and a line. And that's what your crystal is going to be, is this guy right here. That would be him. So your crystal is just two parallel lines with a little box in between that represents your crystal. Okay? As far as coils go, same thing right down here. That's your inductor. These are your coils. Followed by a ceramic capacitor. resistor is a fixed resistor, another ceramic capacitor. Okay. Again, another ceramic capacitor here, and that goes right back out. But yeah, this would be your inductors, your coils, and that would be your crystal symbol right here. And remember, we talk about the chip, right? There you go. Now you see, and this is O2A. That's your PLL O2A, and this is part of IC 101, which means there are different areas that are going to tie into this, which is why you're not seeing all the pins. So, for example, you got pin 3, 6, and 5. Well, where's the rest of the pins? Well, that's because these are different circuits. So where this ties into that part of the PLL chip is going to vary down here to this O2A PLL chip here. So here's the rest of the pinout. Okay. And here's your cluster switch. That's your channel selector for this particular radio, which I don't know what this radio is. Oh, it's a Midland 13857B. Okay. That's what we're looking at for schematic. So we're talking about the variable resistance right here. Is variable resistance. See how the arrow points in? Transistor, diode, electrolytic capacitor, that little plus mark on the left side. Another variable resistor here. That's your volume control versus a small potentiometer on the board. This is your external. That's your internal to the board. And different tuning capacitance as well. So let's talk about that for a moment. Like right here's your tuning capacitance. Your 455 kilohertz. Well, that's a symbol for your tuning capacitance. These are those silver cans you find on the board. That's what's inside these silver cans. Now, some of them have a cap, and in this case does. Some of them do not. Some of them just have a standard coil on both sides to adjust the capacitance. This one here actually has a built-in capacitor, so if you took the can off the board and flipped it upside down, you'd see that cap. And they do burn out at times. Come on, you. I need my papers. Filter. Okay, here's another symbol as a filter, which I didn't put down. Get this up out of the way for a minute. Try to find you one that does not have. Yeah, these all have the capacitance into them. Some of them do not, but these ones all do, so I can't show you. Yeah, this one does. Oh, here's one. Okay. So this guy right here does not have one. He does not have a capacitor. So that's going to be a tuning can to tune the signal here, but it's not going to have a capacitor. It's going to be capacitance changed, but there's no cap additional to that circuit, such as this one here actually has a cap in the circuit. Okay? So, everybody got that? Good question, Michael. Appreciate it. Thank you. Oh yeah, I can do that for you, Boxcar. Sure. So our next video that we do, our next class will be. He wants to know how to calculate the components, such as the sum of voltage when you have like capacitors parallel, resistors parallel, or in series. So absolutely, we can do that for you, no problem. Yep. Yes, those general class, you're going to see a lot of this on general class when you study them, yep. Absolutely. Absolutely, yeah. Well, if anyone's got any questions, like I said, drop them down below. Let me know what your thoughts are. So our next lesson is going to be showing you how to put resistors and capacitors together and see what happens when you apply voltage. If they're parallel circuit or series. So we will do that for our next class, because we're out of time today. We got to move on to repairs, but we will definitely do that in our next class. And we'll talk about voltage dividers, etc., which is what they are used for when you have resistors and caps together in a circuit as such. If you're going to run two caps parallel versus in series, resistors parallel versus series, we will get into all that too, which all falls under Ohm's law. So you got your basic familiarity with that as well. So, okay, guys. Well, thank you all for joining this class. It was fun. Hope you guys learned a lot of these symbols, what they are, and now how you can go further with your self-education when it comes to ham licenses or into your schematic reading or etc. You'll be able to do much more now with that, and maybe further your skills into working on radios, stereos, or whatever you want to do in general. So, and this all applies to automotive, because you're going to see a lot of these things, you know, like your alternators have regulators and diodes and all that stuff too. So this all kind of, it's a formality of everything in life, really. So, but all right, guys, thank you again. Put your comments down below. Appreciate all the support here, and we'll see you soon at the next video at the DX Radio Shop.